Hi everyone. Today in this video we are going to solve a problem based on EMF equation of a DC generator, right? So the EMF equation of a DC generator is EG is equal to 5P NZ divided by 60A. So this is the EMF equation or generated EMF equation of a DC generator. So we are going to solve a problem related to this expression along with these parameters, right? So a problem stated that a 4-pole lap wound. So solution, we will solve this now. The solution, the given parameter is pole, number of poles equal to 4, P is equal to 4. 4-pole lap wound, so it is lap wound, lap winding. DC generator has a useful flux of 0.07 Weber. I mean here phi is equal to 0.07 Weber per turns. This is the flux value per pole, Weber per turn per pole, right? Next, calculate the generated EMF. You need to find EG is equal to how much, right? So we need to find EG when it is rotated at a speed of 900 RPM. Rotated at a speed of 900 RPM. So N is equal to 900 RPM. So N is equal to 900 RPM. With the help of prime mover. Armature consists of 440 number of conductors. So armature conductors, that is Z is equal to 440. Z is equal to 440 here. The given problem. Also calculate the generated EMF if lap wound armature is replaced by a wave wound armature, right? So the given data are for especially for lap winding of armature winding. After finding EG when the generator is wound using lap winding, we also need to find the generated EMF when the armature was winded by a wave winding, right? So we need to find two generated EMF values. One is for lap winding, another one is for wave winding. And these are all the given parameters. Number of poles equal to 4, phi is equal to 0.07 Weber per turn per pole, and speed is equal to 900 RPM, and number of conductors Z is equal to 440 conductors. So we already know the formula for EG, which is EG is equal to 5P NZ divided by 60A, right? So let me solve a problem. Let me solve this problem for first case, that is case 1, lap winding. For lap winding, we know that number of parallel path A is equal to number of parallel, A is number of parallel path, and number of parallel path is equal to P always. We know this relation from the EMF equation of the generator, right? So A is equal to number of poles. So we don't know number of parallel path here, but we know number of pole. They are given number of poles as 4 pole, right? So A is equal to 4 here. So A is equal to 4, right? So we know phi, number of poles, speed, Z, conductors, and A, right? From this, we can calculate the EG for lap winding. That is EG is equal to 5P NZ divided by 60A can be replaced by their corresponding values, where phi is equal to 0.07 into number of poles equal to 4 into N speed 900 RPM into Z 440, that whole divided by 60 into the value of A is 4. because in lap winding A is equal to P always, so number of parallel path is equal to number of poles. So the final answer for this will be, after manipulating these things, values, we will get 462 volt. This is the EG value for lap winding. This is for lap winding, right? So EG is equal to 462 volt. This is the generator voltage when the armature winding is done by lap winding category, right? Now the second one is case 2, which is wave winding. So we are going to solve this wave winding with the help of the same parameters, same given parameters, right? So P is equal to 4, speed is equal to 900 rpm, Z is equal to 440, phi is equal to 0.07 Weber per pole. So P is equal to 4, N is equal to 900, Z is equal to 440, and phi is equal to 0.7 Weber per pole, right? And A is equal to, we need to find A is equal to how much, right? So if it is wave winding, number of parallel path A will be A is equal to 2 always. In previous case, number of parallel path in lap winding, number of parallel path A is equal to P, right? Total number of poles, right? And in wave winding, A is equal to 2 always, right? A will be 2, whatever, irrespective of the number of poles. So again, the generator EMF equation 5P N is EG is equal to 5P N is equal to 60A, which will be replaced by the values phi 0.07 into number of poles 4 into speed 900 into Z 440, the whole divided by 60 into here A is equal to 2. This is the only change between case 1 and case 2, right? Between lap winding and wave winding. So when we solve this, we will get the EG as 924 volt. EG is equal to 924 volt when the armature winding is wave winding. So these are the two cases, and we have solved the given problem. Now let us see the last point of the problem. Also calculate the generator EMF if lap winding is replaced by a wave winding. So we have calculated a EG for generator EMF for lap winding, and it is replaced by wave winding. When it is replaced by lap winding, when it is replaced by wave winding, we are getting EG is equal to 924 volt. When it is lap winding, EG is equal to 462 volt. So comparatively, by seeing case 1 and case 2, EG is twice, generator voltage is twice when we wind the armature winding with the help of wave winding, right? Wave winding category, right? In lap winding 460 volt and in wave winding 924 volt, which is twice, 2 times larger than the generator voltage of lap winding. So for few applications we will always prefer lap winding, and for few applications we will always prefer wave winding. So where voltage is high, we will prefer wave winding category of armature winding, and for lower voltage applications we will prefer lap winding. So I think this is clear. Thank you.